Hello and welcome to this webinar on Amazon S3 batch operations. My name is Rob Wilson. I'm a product manager on the Amazon S3 team, and I'm excited to be talking to you all today. So for today's agenda, we're going to talk about operating at scale in Amazon S3, go into an overview on Amazon S3 batch operations. We'll go through a demo at that point where we walk through the different console views. Then we'll go back to a deep dive on Amazon S3 batch operations to go into more detail on the things we covered in the demo. We'll then review some common use cases and how the pricing works for S3 batch operations, and then we'll leave some time for Q&A at the end. So first, we'll talk about some of the other features that help you operate at scale in Amazon S3, how they fit with S3 batch operations, and how S3 batch operations will help to enhance and allow you to do more with those existing functionalities. Customers choose Amazon S3 for a lot of different reasons, and you see them up on the screen. For some customers, it's about the high availability, high throughput, the scale they can reach with Amazon S3 batch operations and Amazon S3 as a whole. The 11 nines of durability, the ability to store data across multiple regions with cross-region replication. For other customers, it's about the security and management features that we offer, giving you the ability to control access at the object, bucket, and account level, and also to manage your data at scale with a lot of the tools we include to help you control storage classes and manage your storage classes and how an object might move to those over time. In this section, we'll talk about lifecycle management, a little bit about intelligent tiering, our new storage class that automates the movement of data between storage classes. Inventory reports, which is a feature that allows you to list and analyze your objects at scale and fits well with the S3 batch operations feature. So lifecycle policies are a rule-based system that helps you tier objects and expire objects at a certain age. So you're setting up a rule and saying, I want all objects to move to a different storage class after 60 days, for example. And for the expiration, you're then setting a time at which objects should be deleted because they're no longer valuable to you and your business. We'll touch on a little bit how S3's storage class analysis feature allows you to get recommendations and then put those recommendations back into your lifecycle policies. Storage class analysis looks at your data, looks at the access patterns over time, and then shows you what data is frequently accessed and what data is infrequently accessed, so where you see less access on that data. And for a lot of customers, you see that pattern happen over time. So as data is in your S3 bucket for a few months, maybe you see less access after those few months go by. And that helps you then write a lifecycle policy that matches up with those recommendations. And these policies are based on the object's age and can be set by bucket, prefix, or object tag. So it's all age-based, and then you have the flexibility to control the granularity at which that rule is applied. Tags allowing you to write a rule that could cross different prefixes or potentially different buckets. We have 6 major storage classes in Amazon S3, and what you can see here is the organization is frequent storage classes on the left, and then moving to more and more infrequent access patterns for the storage classes on the right. S3 Standard, great general purpose storage class, about 2 cents per month, and this is for frequently accessed data. You're going to get millisecond access, and you're in 3 availability zones. When you move to the middle, you see our infrequent access storage classes, standard infrequent access, and 1 zone infrequent access. And then to the right, you see S3 Glacier and S3 Glacier Deep Archive, which are archive storage classes optimized for colder data that you're going to be storing for the long period of time and you want to save on costs. For those infrequent access storage classes in the middle, it's a lower storage cost than S3 Standard, and there is a retrieval charge. So you want to think about what data is best suited for infrequent access storage. If you don't want to manage moving data between these different storage classes and thinking about what storage class is right for you, intelligent tiering really gives you the best of both worlds. It allows you to have no retrieval fees on your data, and you're storing the data in a frequent and infrequent tier, and S3 is looking at the access patterns and moving the data between the frequent and infrequent access tier based on the access patterns. So we'll go into it in more detail later, but it's a great way to hand off the management of your different storage classes to S3. Here's some examples of lifecycle policies in action. For one, this customer said after 60 days, move the data to standard infrequent access, and then after 180 days, move it to S3 Glacier. In this example, the customer started in Intelligent Tiering storage class, and after 180 days wants to move the data to S3 Glacier. And then you can add on an additional policy with the launch of Glacier Deep Archive that now you can move from standard to S3 Glacier after 180 days, and then after that first year of the data being in S3, you can move it to S3 Glacier Deep Archive and really save a lot on storage. Now we'll go into a little bit about intelligent tiering. So intelligent tiering, when you put an object into the intelligent tiering class, it moves it to a frequent access tier, and it's initially placed there. If the object is not accessed for 30 days, it then moves to the infrequent access tier. There are no retrieval fees. You're paying a monitoring fee for us to do this movement, and what you benefit from is the pricing difference between the frequent and infrequent access tier. The frequent tier is priced the same as S3 standard. The infrequent tier is priced the same as standard infrequent access. So the more of your data that's not accessed, the more moves to infrequent access and the less you pay for storage. So you can achieve about 40% savings by using intelligent tiering when the data moves to that infrequent access tier. This is a recap of some of the things we talked about on the previous slide. Some of the things you really want to pay attention to is it's still millisecond access, you're still in 3 availability zones, and you have no performance impact. So there's no operational overhead to manage the storage classes. There's no difference to your end customers if you're storing their data in S3 intelligent tiering. So it really is a great storage class for a lot of customers to consider. And this could be beneficial because maybe you manage a big data lake, and you have many different applications accessing the data, and those applications may have widely different access patterns and different needs over time. It can be hard to predict exactly the access patterns because of how much is happening in that data lake. So it'd be a great fit for intelligent tiering, where then on the object level, S3 is managing that movement between the frequent and infrequent tier and handling the optimization for you. For enterprises, you may have a case where many different teams are accessing certain objects. So because of this, once again, it's hard to align and understand what are all those teams, what are their roadmaps, how is this data going to be accessed over time, and how does this data differ across this entire bucket or across this organization. Intelligent tiering, a great fit, object level granularity, and that work is all handed off. And for startups, we've seen a lot of excitement in intelligent tiering because of just how strapped startups are. They need to focus their resources on revenue-driving initiatives that are going to help grow their business. They've got a lot of work to do, they're growing a business, and managing storage classes might not be high on their priority list, so why not use intelligent tiering and hand off that work to Amazon S3? The Amazon S3 inventory report is a list of objects, so this can be configured to list everything in a bucket or everything in a prefix, and it's really good for analytics and auditing. So it helps you answer questions like, is there anything that's not encrypted in my bucket? You're going to have a field that you can then query on and say, show me all the objects that are not encrypted. And you can quickly get to those objects and then take action on them. Similarly with replication, you can see what objects are replicated, what objects are pending replication, and what objects are replicas because they've been replicated from another region. So you can really get to the details about the objects stored in your bucket. Retention dates refer to our new object lock feature. So that is a feature where you can set a compliance mode or governance mode date on an object, and it dictates how long that object will live before it could be deleted. So it basically blocks deletes on that object until that period is reached. And then you'll also see information about your objects such as the key, version ID, size, so you can answer other questions as well, especially with the size information, filtering your bucket on how many of the objects are larger objects, how many of them are smaller objects, and really do some filtering that might help you make decisions about storage classes, what to move to intelligent tiering. Could be a lot of information you could draw from that. So now we'll move into an overview of Amazon S3 batch operations. We're going to talk here about how the feature works at a high level, and that'll help us set up for the demo, where we'll then dive into the console view and see how it works step by step. So customers asked for a feature here that would allow them to not do scripting and not build their own tools to call APIs in bulk. A common thing you could imagine customers run into in S3 is, I want to copy terabytes of data to another bucket. I want to copy terabytes of data to another customer. Or I have archives in Glacier that have been building up over time, and now that we've moved a lot of our data to Glacier, I have millions of objects there, and when I want to get them back, I need to get back thousands or millions at a time. And that becomes a scale challenge for a lot of customers, where if you don't have a tool on hand, you'd have to spend some time building that tool. So with S3 batch operations, you're going to save on the operational overhead of running that operation and managing that tool, and you're going to save on the time that it would have taken to build that tool. So now you can manage billions of objects with a single request. You're handing off that work to Amazon S3, and it really is a solution that gives you all the functionality you'd need for these bulk operations. So how does it work? Well, we're going to talk about it here at a basic level, but you choose the objects by handing a list of objects to batch operations. That could be a CSV that you've customized and built off of a query or some secondary database you have, or you could just hand S3 batch operations an S3 inventory report. So this is, once again, that list of everything in a bucket, everything in a prefix. If that's the group of objects you want to operate on, you can hand that list directly to S3 batch operations. Then you go ahead and select an operation. We'll go into these in detail, but at a high level, it's things like copy, tagging, applying access control lists to objects, restoring objects from Glacier, and performing Lambda functions. So adding the ability to invoke a Lambda function for each object in your bucket gives you tons of flexibility to then think about what operation is then going to be performed as part of that Lambda function. And then you're going to have things like the ability to view progress and see state changes as your job progresses along the way. So in this case, a customer would be able to say, well, my job's 75% done, and that's exactly the state of the world, and I understand how far the job's come, and you can kind of make and build estimates on how much work is left to be done. So this is just a different view, but it shows you in a little more detail that you can use an S3 inventory report in the CSV format, or a CSV list that you've built to specify the group of objects. You can then perform one of these 5 operations. So there are 4 native S3 operations that work very similarly to the APIs that you're familiar with today, or you can run a Lambda function. And then you can view progress. So it's object level progress like we just saw, where it's showing you 75% of the job's complete. You're also seeing a granular count of successful and failed object operations. So if you have 1 million tasks as part of a job, you're going to see that count and see exactly how many have been done at any point in time. Job notifications show you when a job is first added to S3 batch operations, when it goes active, and then later on when it's completed. So you'll see those different states, and there are other states as well that we'll see as part of the demo. And then for completion reports, this is an audit record of everything that S3 batch operations has done. So you can specify a completion report for all successful tasks or all failed tasks, and you have the ability to control that and choose what's right for you. Here I want to show you briefly the console list view that you'd see for S3 batch operations. So you can see I see a few jobs here. You can actually load up to 100 in a single page. You can see the job ID, which is a unique identifier for each job. The description is something you can customize. So I leave the dates here in my own examples, but you can take those dates away, you can add strings, you can talk about what team or why a particular job is running, just so you and others in your organization have an idea of why a particular job is running. The operation shows you which of those 5 operations is being performed. The date created is self-explanatory. The status shows you the job state. So these jobs are all complete, but you may see jobs in the awaiting confirmation state, in the ready state, active state. Jobs can be paused for reasons that we'll discuss later on. So you're going to see exactly where each job is along the way. The total objects is the count of objects listed in that manifest that I handed to batch operations to perform this job. In this case, the job is 100% complete. There were no failures. And we also have the priority level that we'll go into in more detail later on. One of the reasons customers really like batch operations is that it's a managed solution. So you're handing off the work, you have the visibility you need, but everything else is being handled by S3. We have automated retries, so if for any reason an object isn't completed right away and it's something that we can retry again and be successful, we'll handle that within S3 batch operations. You have the progress visibility we talked about. You have the controls to change priority and adjust which jobs are running at any particular time. And then you have the ability to cancel jobs and take other actions that you need to manage your overall S3 environment. We also have notifications. So for those job state changes we talked about, you can use CloudWatch events to send you a notification. So you'll know exactly when your job reaches a completion state and you can kick off some other operation. And then for auditing, we have those completion reports. So really, when you see these features packaged in S3 batch operations, there's no need to build and maintain an application to call APIs in bulk. You don't need to build your own tool. You don't need to find a tool and learn how to operate it. You can just hand off these large-scale jobs to S3 batch operations. So now we'll jump into the demo, and this will give you a detailed view of step-by-step how you can walk through the S3 console and create a job and get it running in S3 batch operations. To orient you to the demo we'll be running today, we have about 800 images stored in an Amazon S3 bucket. These are images related to space, some of the work that NASA does. So these were images that were just taken from the internet and stored in this bucket. S3 batch operations, as part of this job, will invoke a Lambda function. This is a Lambda function we wrote for this particular demo. That Lambda function calls Amazon recognition, then performs image recognition on each of those images, and grabs certain attributes and labels. So what is it seeing in the particular image and what can it classify? Takes those results, sends them to Amazon Elasticsearch, and then we're going to show you a Kibana dashboard that populates as this demo is running. So you'll see that dashboard change once the job is kicked off and once those labels start to populate. So this is one example of what Lambda can do. There are obviously infinite ways you can use AWS Lambda with S3 batch operations, but hopefully this shows you just a little bit about what you can do with this feature in Lambda. So let's jump over to our demo. Here we are in the S3 batch operations portion of the S3 console. So you see we select that by going over to S3 batch operations over here in the sidebar. So I have my view of buckets, but here we're going to start in S3 batch operations. I have a job here. I can see this is my Lambda demo that I ran before. So we're going to go ahead and clone this job. That's a really cool feature. It's something available in the console, and it really simplifies creating multiple jobs. In many cases, you may use this to just change something slightly for a particular job. So I want to do the same job, the same operation, like let's say add these particular tag values, but I want to do it to a different set of objects. So using clone job and just switching the manifest in that case would work really well. So we'll walk through that view right now and clone the job. Takes us to our first screen here, and I'll really talk through each of these screens in detail to give you an idea of how this feature works. So this talks about how we copied over the properties from another job, and you'll see that everything's been pre-populated as a result of that. Our region here is US East, and the region will be the region where the objects are located for every operation except the copy operation. For the copy operation, you'll want to choose the region, which is the destination for the particular job. So if you're copying across region, you'll want to think about what's the destination region and make sure you select your region accordingly. Next, we're going to go into selecting our manifest. In this case, I'm using an S3 inventory report that was generated for this particular set of photographs. So I stored those photographs in an S3 bucket, I created an inventory report, and now this path right here is pointing to the manifest.json file, as you see right here, for the inventory report. That manifest.json then lists all the data files that show you what objects were actually in the bucket at that time. And now we'll go on to the next screen. So here's where you actually select the operation and what's going to be performed today. In this case, we'll be invoking an AWS Lambda function. And as we scroll down here, you'll see the details about that particular function. For those of you interested in more detail about how this works, what we're doing is we're calling an individual Lambda function for each object listed in the manifest. So in this case, there are about 800 images, 799 to be exact, and we're going to call a Lambda function for each of those objects. And what S3 batch operations is passing on is the key name and some other information about the objects in this particular job. Lambda then reads that information and takes action based on the object that's passed along. So that's what's allowing, in this case, an object to go from your S3 bucket through the Lambda function over to recognition, store the attributes in Elasticsearch, and then you'll see that action take place on the dashboard. So this is our NASA demo. We're going to use the latest version of the Lambda function. So you have the option here to say there is a particular version that I uploaded of my Lambda function that I always want to call. In this case, we only have one version of it, but it may be something valuable to you to use the latest one if you're going to be updating that Lambda function along the course of a job. So you have that flexibility, and if the Lambda function changes during the course of this job, that would be taken into account, and that newest version of the Lambda function would be called by S3 batch operations. So something to think about and something you might be able to be creative with. In the next screen here, we're going through some additional options. So this will map back to some of the things we talked about on the dashboard view. So let's see. We have our description column here. We're going to call it Lambda Demo, and we are doing a webinar today. So let's recognize that and let's celebrate it. Our priority we're going to set as 15. You'll see how that fits in later on. I typically keep my jobs around priority somewhere between 1 and 25. That gives me enough different levels to work with, and you'll see how those numbers can come into play later on. You do have a lot of flexibility to pick your priority number here, though, so you can pick a different range and set those within your organization in various ways. During the example later on, we'll talk about how you might want to set different levels and kind of think about what types of jobs should be at different priority levels. And the thing I'll just emphasize at this point is priority is only really relevant relative to other jobs. So if I have one job at priority 15 and another job at priority 10, the priority 15 job is higher and would take precedence over the other job. But kind of inherently on its own, the 15 and 10 don't matter. It's really just relative to one another. So pick a naming structure that works for you. I do want to generate a completion report for this particular job. I'm specifying all tasks because in this case, I wrote a Lambda function that returns the exact results from recognition back to S3 batch operations. So for this particular demo, we set a threshold of 97% confidence or more. We would need to be that confident in a label from recognition before we'd recognize it and populate our Elasticsearch in our dashboard with it. If I want to dive in later on and say, why did that particular image not have any labels? What was wrong, or was it a quality issue in the image? Was it something where, I need to troubleshoot different ways or look at my kind of image pipeline? This completion report will allow me to go into that detail, look at a particular object and see what was the results set returned from the Lambda function. So that'll give me the ability to dive in later on. That's why I specified all tasks here. For other jobs, you might say, well, I only really care about the failures. I'm operating across billions of objects. I'm going to be tagging them all. I really want to only know if something went wrong. So that's a case where you'd select failed tasks only, and that would give you the ability to really isolate exactly what you want to see in the completion report. For customers that do select all tasks in their completion report, we do separate successful objects from failed object operations as we write the report. So you will be able to look at your reports manifest and see successful and failed files objects, and they'll be in different files to help you ramp up and get that information a little quicker. And then I just specify a destination for my completion report, which maps well to this next section where we talk about permissions. So at a basic level, S3 batch operations is acting on your behalf. You're taking a list of objects, you're specifying what work is supposed to be done, and you're handing that off to S3 batch operations and saying, perform this task for me, perform this operation for me across all these objects. So S3 batch operations needs the permissions to perform that operation on your behalf. If those permissions aren't there, the job will fail, and you'll have to adjust the permissions to make it successful. So let's use this drop-down arrow here and start talking about what some of those permissions are. In this case, the operation we're performing is to invoke a Lambda function. So in this case, we gave permission to invoke Lambda functions as part of this IAM role that's being specified for S3 batch operations. What we're viewing here is really a template and kind of guidance from the S3 console as you're walking through. And then for my particular IAM role that I build in the IAM console or through the APIs or CLI, you can then tweak this slightly. But you'll see some recommendations here that'll help you ramp up. So as part of this set of permissions, I'm giving the invoke Lambda permission, and they're specifying the individual function that we specified. So that's a way to really scope down exactly what Lambda function can be performed. In this next section, we're looking at the permission to read the manifest, to read that list of objects. So this was the inventory report I stored for my NASA demo photos, and it was stored in this demo bucket, and then it specifies the date timestamp of the particular one we're using. So we're using one from a little while ago, and that gave us our authoritative view and list of the photos. So that's the file we specified earlier, and now I have get object version, the ability to read that as part of this job. And then this last section, because we specified we wanted a completion report, well, I need permission to write that completion report. So here's the bucket we're writing to, here's the individual prefix we specified, and now put object permission, and having the ability to do that operation allows us to perform the full job. So looking at this again and kind of showing you the whole view, this is the operation we specified, this is the ability to read the manifest, and down here is the ability to write the completion report. Now the other thing you'll see here as you go to the other tab, and we have a section on this in the slides as well, is a trust policy. So a trust policy dictates what principals can assume a particular IAM role. In this case we're using the feature S3 batch operations, and this will have to be specified as part of your IAM role creation to allow batch operations to assume this role and then perform the operations on your behalf. So make sure you include this trust policy as part of creating an IAM role. In this case, I'm choosing from one of my existing IAM roles that has already been built, and that's my batch operations Lambda demo role. So now we've specified all the information we need for a particular job, and we're just going to go down and confirm that everything looks correct. So we have our region, our manifest selected there, the operation we're performing, the name, basically the description we gave to this particular job we're going to perform, priority level, I did want a completion report, and that's our IAM role. So when we click clone job, we're going to see this message back on our dashboard screen where we've successfully created that job, and you'll see it right up here at the top. So that's our Lambda demo webinar, and it's in the preparing state right now. If I go ahead and refresh this view, we've already seen S3 batch operations read through that manifest. It's pretty small at 800 objects. But once we read through the manifest, you now see awaiting your confirmation, and you see the count of the objects listed in that manifest. So before, this was blank, but after the manifest is read, the job moves to the awaiting confirmation step, and the objects are visible. So this is really one of the key attributes and key things you want to check before you then activate and run a job. It's the one piece of information that might not have been wasn't available earlier when we created a job, and now it is. So we walked through all the other selections we made as far as what's the manifest, what's the operation I want to perform, what IAM role to use. We confirmed that already. Now when you go back and confirm the job in this awaiting your confirmation step, the one thing you really want to pay attention to is how many objects. Because you're going to go into a particular job with an expectation, and if that expectation is not met, maybe the wrong manifest is selected, maybe something else went wrong, but you want to check that number of objects to make sure the right job's being performed on the right objects. Now before we confirm that job, I want to take you over to our dashboard view. So this is a dashboard we have auto refreshing. It's in the Kibana system, and we're going to see a few different things populate. We're going to see how many labels, how many bucket keys were read, so how many keys from S3. When we scroll down a little bit, we're going to see our top labels, and then up here we're going to see objects, and about 10 objects at a time, and what labels were identified for them. So right now we've got a blank dashboard. There's no information in this Elasticsearch query that we're running. So once this job runs, then the data will start to flow from Lambda to Recognition and over to Elasticsearch. So back to our job here. We're going to select the particular job we looked at a second ago, and we are going to confirm it. You'll see this screen is very similar to the screen we looked at a second ago. So this is once again showing our job details. As I scroll through, now I see the total objects listed on the manifest. 799 is exactly what I expect here. The priority is still 15. It's in a waiting confirmation state. And I'm ready to run the job. So we click Run the Job here. And now that we are running the job, let's go back to our dashboard and see what we can see here. So once again, the thing we're going to see as the job starts to run is we're going to see the labels as they come in from Amazon Recognition. Go back over here. And our job is active. So it may take a second for a job to ramp up and start running, and we'll check that right here as it starts to populate. Now we're starting to see those results flow through. So this is interesting. We talked about these are space-related images. See things like people, there might be astronauts in the particular images, clothing, crowds, overcoat. In a couple of these other ones, you'll start to see some other things that we see. This one's interesting. So Spire building architecture. You could picture a launch pad in a particular image. Workshops. So you see the full kind of engineering work that goes into a particular launch. Up here, you're seeing rockets, forms of transportation. So these are labels being generated from images that might have been static in S3. They might have been archive images that were sitting in S3 for years until we really went in and said, what do we have in S3? What can we make from these particular images? Should we be sharing them online? Can we share them with our partners? What can we do with our business now that we know we have this information? So we generated 1,700 different labels from these images. Because we set that confidence level at 97%, this is showing us that only 508 of the images out of 799 met that high threshold for having confidence in the labels. So that's why you're not seeing the full 799. And then down here, you're seeing a mix of what were the different properties and how popular were they. So we're seeing these different labels that we talked about before: space, outer space, astronomy, outdoors, night, moon. These are all to be expected on this particular set of images. So it's really cool to see this come to life, that when you run the job, the Lambda function kicks off, you can really generate a lot of information very quickly with batch operations. It's not something where I had to worry about that part of a particular workflow. I just skipped right ahead to, if we can build a Lambda function that does this, S3 batch operations will do all the heavy lifting for me and really access all these objects. So now we can see that job. If I refresh here, you'll see one more status check on that particular one. And that job is complete, 100% done. So a job of that scale is going to run very quickly, and then as the jobs scale up, you'll be able to see their progress. So let's scroll down a little bit. I've got a job with about 2 billion objects that's running right now, and that's at about 2% completion. And then I've got a job below that. So let's go ahead and filter to the in-progress jobs, and I'll show you those two. So this is a job with about 2 billion operations going, 2% complete at this point, and that job will continue to run. And then here we have 220 million objects in this particular job. That one's 5% complete. So very easy for me to look at a job, very quickly understand where it is, what state it's at, and most importantly for me, just checking that there are no failures for this particular job. Everything's running. It's just a matter of S3 batch operations working through that particular job. So let's move back now to our slides and talk a little bit more about what we just saw in the console view. So now we'll walk in through a deep dive and we'll talk about some of the different things we touched upon very briefly in the console view there as we got that particular job up and running. For manifest creation, it's once again a CSV inventory report or a CSV file that you create on your own. The required fields are just bucket and key name. So it's very simple. You really only need that information for your particular objects. Version ID is optional, but here's why you might want to specify that for a particular job. If your bucket is versioned and has versions of objects, if you want to make sure we operate on that exact version of an object, you'll want to specify the version ID as part of a job. As you saw from one of those jobs I had running in my dashboard, with 2 billion objects running, that may take some time before the full job completes. So if I don't specify version IDs and I just specify the bucket and key name, the object itself may change during the course of that job. And then it becomes hard to predict exactly what object was in the bucket at the time S3 batch operations got to that particular object. By specifying a version ID, I know exactly the set of objects I'm specifying because that version ID refers to a specific version of an object. So something to consider as you're building your jobs and if you use our versioning feature. So you might be wondering, how does S3 batch operations execute the job? Well, the good thing is we call the existing API. So what you might already know about, let's say, restoring objects from S3 Glacier, that's going to carry over to using S3 batch operations. Calling these APIs, you'll see AWS CloudTrail support, just the same as you were if you called that API yourself. We allow you to customize the API's parameters. We'll go through some examples later on, but you'll see the properties and parameters you can specify for restoring objects from Glacier, the information you can pass for tagging objects. Be very similar, if not exactly the same, as the APIs you might be using today in S3. It requires the same permissions as the existing API, so it's going to make it a little easier to use that IAM role, and then things like bucket policies will apply in both cases. And then it makes it simple to use S3 batch operations with your existing applications. If you already have tools, applications, other parts of your system that are restoring objects, tagging objects, and so forth, it's not going to look different to your end customer. It's not going to look different to others within your organization, whether you're using S3 batch operations or your existing tools, or performing the same API operations. When you're setting up permissions, as we talked about right at the end of that console walkthrough, you'll want to think about a few different things. Permission to read the manifest of objects, permission to perform the action specified. So the demo we just walked through was for a Lambda function, but you could be performing one of the 4 S3 operations as well, such as tag, copy, restore, or changing your object access control list. And then writing the optional completion report, something that we recommend just to have an audit report for any particular job. You can choose if that's only for successful or failed tests, but it really is a good recommendation to just set up that completion report and have it saved. And if you're going to set up the completion report, you want to include permissions for writing that completion report to the bucket and prefix of your choosing. Some cross-account considerations, and this is a popular topic. A lot of customers, have partners or other parts of their business that might be in different AWS accounts. If you want to copy objects to other AWS accounts, it's a good best practice, and it's important to think about these things. So writing your S3 inventory report, if that's what you're going to use for a particular job, writing that report directly to the destination account allows you to more quickly get the job up and running. Because that S3 inventory report is owned by S3, and we're the ones who write it to the bucket, having the role within the destination account read the object within the destination account will allow that to be successful. So that's something you'll want to do if you're using S3 inventory reports, is just write it to the destination account. The other thing to consider is, who do you want to own the objects at the end of a particular operation? If you want that to be the owner of the destination bucket, then you should assume an IAM role and specify an IAM role for the batch operations job that's in that destination account. That will ensure that the copied objects are then owned by that account. It allows them to do more with those particular objects and get the full value out of storing those objects and using them in S3. So a couple things you want to think about for cross-account S3 batch operations usage, specifically tied to copy. And this example, there are examples of this in our documentation. The trust policy, I'm just going to talk about it one more time. So for particular IAM role, you'll want to specify that S3 batch operations can assume that role and perform the action specified for a particular job. Reading the manifest, performing the operation, and writing the completion report. This is something that needs to be there in the IAM role, or the job will fail. So a couple things real quick, just a few bullet points to talk about customizing an S3 batch operations job. You can specify whether or not the confirmation step is required. We saw that happen with the console. The console always defaults to requiring that confirmation step to make sure you have that chance to go through a job, confirm the number of objects is correct. But if you call a job through the API, SDK, CLI, that's something that will be optional. And you can turn off that confirmation step if you want your job to just run through to completion once you specify and pass on the job to S3 batch operations. The next one is the ability to set different priorities. And we've got an example that'll show you how different jobs may affect one another if their priorities are changed. So we'll go through that as part of the example. And then specifying the information to include in your completion report not only refers to specifying successful or failed operations, but also thinking about what result set might be returned from something like a Lambda function. So in the case and the demo we just ran through, using recognition and passing those labels back through the Lambda function allows you to then have a record of all of those in one place in your completion report. So it's great to go back and do analysis there. So here we'll talk about how priorities might be used. In this case, we've got 5 different jobs. So I specified a few different operations there on the left side. One of these jobs is tagging all objects. Another one's copying objects. We're restoring objects from Glacier from a particular prefix, changing access control lists, and then doing our Lambda demo. So we've got 5 different jobs here. 4 of them are active and one's in the ready state. So when you're looking at this, you're saying, well, those are active and running, and this other one's ready state, but I want to run my Lambda demo now. Like, they're all at the same priority level. What if I want that Lambda demo to run ahead of one of the others? Let's say it's more important than all the other jobs. So I would just want to take the Lambda demo's priority and raise it to something above 10, which is where every other job is right now. So if I want my ready job to move to the active state, let's adjust its priority. In this case, I take that job priority, I change it to 15. What then happens is you'll see your Lambda demo job move to an active state, then you'll see one of the other jobs pause. So you'll only see this behavior if you have many jobs running at a time, but you will see a situation where only so many will activate at a particular point in time. And in this case, with a job in ready, we had already reached the max number of active jobs. So my Lambda demo now moves to an active state because of its priority level, and that job to change the access control list moves to the pausing state. After some period of time, it will then move to a pause state, and it will stay there until its priority level once again allows it to activate. So that may be after some of these other jobs complete, or if many more jobs are created at priority 15, it may take some time before that particular job runs. The dashboard view that we showed earlier, I want to emphasize that it is a regional view, so you can see all the job activity at the account level in a particular region. So that might be your team, that might be other teams within your organization, so it's important to think about something like the job description that you add to make sure you have enough detail there so people can look at that dashboard view and understand what particular job is doing what. So you'll see all jobs in a region, you'll see their job IDs, which are the unique identifiers, what operation, creation, date, and all the other fields we talked about before. And then when choosing the regions, we touched upon this briefly, you want to choose the same region as where the objects are for every operation except for copy. And in copy, just think about where the destination region is for that copy. So if it's the same region for a copy operation and the objects are being copied to the same bucket or a different bucket in the same region, not much to think about there. But if you are copying to a different region, think about what that destination region is and specify the region accordingly. On job progress and notifications, CloudWatch Events allows you to push those notifications when job states change. So now that we've talked through some examples there, you saw jobs go from the preparing state to the ready state, active, awaiting confirmation. There's a completed state at the end. There's also a failed state if a job is not successful for whatever reason. So those state changes can then be something that is sent through CloudWatch Events and could send you a notification as particular jobs are running. And then for job progress, you have a few different ways to see this. So through the management console, you have that dashboard view overall that we looked at. And as part of the list view, you'll see the progress of all the jobs that meet a particular criteria. So that may be all jobs in the Northern Virginia region for a particular account. And then for the Describe Job API, which is equivalent to clicking on a particular job in the management console, you'll be able to see the count of successful tasks, failed tasks, and then the percentage complete of a particular job. For completion reports, you can specify successful or failed, and then what you're going to see is you're going to see the bucket, key name, version ID of a particular object, whether the individual task was successful or failed, the status code of any particular error, description of that error, and then additional details or result set. So when we talked about AWS Lambda sending information back from the recognition call and what labels and attributes came from a particular image, you would be able to see those in your completion report if you set up your Lambda function that way. Now a quick note on S3 batch operations pricing. So just to make sure as you're looking at this feature, you're saying, well, what's it going to cost me to get all of this convenience of S3 batch operations? We'll just talk through it now, and then we have an example later on. So it's 25 cents per job. That's just a flat fee for any job you perform. And then $1 per million object operations refers to how many objects are listed in your manifest and how many object operations are performed. So that number is prorated. If you only did one object, it would be 1/1,000,000th of that $1. And then the object cost will scale depending on how many objects are part of a particular job. The thing to note is there are requests as well. So things like listing your jobs in batch operations or getting the description of a particular job, those will have charges similar to the S3 requests that you have today for list and get in that case. And then you're also charged for the operation that's happening. So if it's Glacier restores, we'll look at an example of this. There's a number of gigabytes that's restored. There's a number of requests to Glacier. And then for things like copy jobs across a region, you may have things like data transfer to take into account. For Lambda, you'll have requests to Lambda plus the runtime of your Lambda function. So just think of that overall cost of an operation and what's being performed when you think about the cost. Here are some common use cases. We'll go through some detail here. To encrypt existing objects, so you can filter down to what objects are not encrypted right now using something like an Athena query to look at your S3 inventory report, look at what's not encrypted today, and then specify to S3 batch operations, take these objects, copy them to the same bucket they're in today, so they'll basically write over themselves, And then in this case, you're specifying the encryption type, so then it will encrypt those objects when they're rewritten to S3. For this next example, just copying objects to a new location. Now you have the flexibility to create a job, copy to a different bucket, a different prefix, a different region. You have all kinds of flexibility there to move data across Amazon S3. With this example, you may also use S3 batch operations and copy to move to a different storage class. So this would be an alternative to lifecycle policies. With lifecycle, as we talked about earlier, you could write that rule for a bucket, prefix, or object tags. So you could use batch operations to tag objects and then use lifecycle. And that has benefits because a transition does things like preserving the object creation date. So if an object being first added to S3 4 years ago is a valuable piece of metadata that you use, that you make decisions off of, lifecycle is really the way to go. But if you want to copy the objects because you have a particular set of objects that you just want to say, I just want to move these 1,000 objects to intelligent tiering, and it's something where you know the exact objects, so you just want to take action on them right away, something like copy will allow you to do that. So you would specify, once again, the same bucket as the destination for that copy job, and you would just change the storage class. So then when those objects are written back to S3, they would be copied with that new storage class. If you have a version bucket, you'd then want to go back and clean up the kind of previous versions of the object using lifecycle policies with non-current version expiration policies. Plenty of detail on that in the documentation, but this is a way you could change the storage class. Just note that it'll reset things like the creation date to the date the job is performed. In this restore objects example, very few parameters you have to specify for restoring objects. It's the number of days you want to keep a temporary copy of that object restored. So the original stays in Glacier and you're creating a temporary copy in S3 that you can interact with. And in this case, I'm specifying the bulk retrieval option because I'm restoring a lot of data and I really want to take advantage of that low cost for using bulk retrievals. So talking through an example of what that particular Glacier restore would cost, we're looking at 1 million objects. I made them about 1 megabyte each for this example. So you see that number of gigabytes is just slightly rounded based on the power of 2 that's involved here. So the one job, 25 cents, 1 million objects, that's just $1 per million. 1 million restore requests ends up being $25, and then restoring 977 gigabytes of data, which is a pretty good amount, is only $2.44. So that adds up to $28.69, and then you see what batch operations is relative to the overall operations cost, and what you'll want to think about when you create a batch operations job, just the different elements of what might be involved. So S3 batch operations is good for recurring and one-time workloads. So I've got a few examples up here on the screen. I'll touch on a few. Performing bulk Glacier restores to run periodic reports. Maybe I'm always pulling back the data from the last kind of trailing 2 years ago. And doing something like that through S3 batch operations, that team wants to focus a lot more on the analytics and the insights, and maybe less so on the management of moving objects from Glacier back to S3 to access them. On the right side, with some of these one-time things, encrypting data, so getting that one-time encryption done, because you've already turned on the default encryption feature in S3, you're already encrypting the new data, you just want to go back and encrypt the old stuff. Doing that with S3 batch operations is something to help you cross that off your list that much faster. And then tagging existing objects is another way to say, I didn't add the tags when I first wrote this object to S3, I want to go back and tag it now, create a manifest, use S3 batch operations. So now we'll leave some time for Q&A and talk through that. I know we've got some questions in the chat. We'll answer those as we go on. And then I want to say thank you to all of you. So I really appreciate your time today. I hope we were able to teach you a lot about S3 batch operations. There's tons of other material in our documentation. There's a few videos to help you get started. And then we'd love to hear your feedback. What other things do you want us to build into S3 batch operations? And how else can we help you get the most out of this feature and out of Amazon S3? I'm Rob Wilson, a product manager on the Amazon S3 team, and thank you very much for your time today. Bye-bye.